Good day, student. So, I welcome you all to this series of classes for JAMB, WAEC, and it's also suitable for the senior secondary school from SS1. So, this will be a series of classes that contains other subjects too. But for now, we start with the physics. Where we'll be able to work more on that. So what we be discussing is unit and dimension. Now, if you remember our definition of physics, physics can be defined as the study of the relationship between energy and matter and the application in real life. It's a branch of science that we call the physical science, and it consists of both physics and chemistry. Okay, so when we discuss matter, anything we remember in junior secondary school, we define matter as anything that has weight and occupy space. That is, it has weight and volume. That is what we refer to as matter. So in physics, we discuss a lot of matter, and basically that is what we'll be discussing. Now, anything we discuss in physics, we refer to them as quantity. Quantity is any parameter or any things that we are discussing in relation to the matter. So basically we refer to them as as a physical quantity. That's how we now said all quantity in terms of which law of physics are described and which can be measured directly or indirectly are called quantities. Any parameters. So for example, mass, length, time, speed, force, momentum, potential difference, energy, pressure, temperature, current, voltage, anything that we discuss, any terms, any quantity at all that we discuss in physics, we refer to them as quantity. Okay, now this quantity, we have two types of quantity. We have the fundamental quantity and we have the derived quantity. What are fundamental quantity? Fundamental quantity, these are quantity that does not depend on another thing. Okay, they do not depend on any other quantity. That is, they are the basis quantity, the base quantity, the basis of our study in physics. Okay, all other things that we are studying will be built on them. Example are mass, length, time, temperature, electric current. In some cases, there is electric charge, luminous intensity, that is of light, and the amount of substances. However, generally, we have three of these quantities that are very, very important that we use a lot, and those are They are the length, mass, and time. Those three are They are the most important of all the physical quantity. Okay, so the physical quantity are those quantity that they do not depend on any other quantity. So we call them We call them the fundamental quantity or the base quantity. So we now have derived quantity. Derived quantity are quantity which depend on fundamental quantity. That is, they are based on on other quantity. A good example of that is speed. Speed, when you define speed, we say speed can be defined as what? The rate of change of distance with what? With time. That is, we say speed is equals to what? Time, distance over time. Now, distance is a measure of the length. Okay? And we said, if you remember before, we say length is what? Is a fundamental quantity. Why time is what? Is time itself. Okay? So we can see that speed is gotten by what? Dividing time, distance over what? Time. You divide the distance by what? By the time. Then we get what? Speed. So therefore, speed is a derived quantity that depends on two fundamental quantity, which are what? Distance and what? And time. Another good example is density. Okay? Density. And density can be defined as what? As volume per unit. Sorry, the mass per unit what? Volume. Density is the mass per unit volume. That is mass over what? Volume. Now, mass is a fundamental quantity. Okay? But volume is not a fundamental quantity. So volume is length times breadth times what? Times height. Okay? So in that sense now, the volume is also related to what? To the what? To the length. A length multiplied by itself 3 times. That will give you what? Volume. You can now see that what? Density is a derived quantity that depends on what? On mass and what? And length. So that is the difference between what? That is what we mean by what? Fundamental quantity and derived quantity. So let's look at the difference between the two of them. Difference between fundamental and derived quantity. Fundamental quantity, one, they are based on an international system. Okay, we have the system that is agreed by the scientists, and they are based on that. So they are the basis, they are the foundation of the system. Why derived quantity? They are formulated from the international system. Okay, so you can see the difference. Fundamental is at the base, why the derived quantity are what? They are developed based on formula that depends on the what? On that system. Okay, now 2, the fundamental quantity, they are the basic unit of measurement. Okay, if you are measuring anything, they are the basics. Why they are the derived quantity are not what? They are not the basis of measurement. 3, they have direct calculation. The fundamental quantity, they can be calculated direct by themselves. They are not depending on anything. If you want to get your time, you measure your time directly. You can calculate the time between 2 hours and 3 hours. You don't need any other thing. So in case of time, for example. Okay, but when we are talking about the derived quantity, their calculation are derived. Okay, for example, as I said, speed and what? Time. Speed depend on distance and what? Time. The distance does not depend on anything. If I move from here to my 2 now, okay, I move from somewhere in Ojo to my 2 in Lagos State, I can take the distance of the point I start then to where I stop. The distance between them, the space, that gap, if I measure the length of that gap, then I have my what? Distance. So I don't need to do anything. But if I'm looking at the speed, I have to know, after getting the distance, I have to divide it by what? By the time. So I'm doing a calculation that depends on the distance and what? And time. So for the fundamental quantity, they are generally acceptable quantity. Okay, they are basic. Anywhere you go, you are accepted. Why the derived quantity, they are just accepted based on the formula. Okay, so and can depend on that. Then 5, the fundamental quantity, they can stand alone. Okay, they are independent of some. They are not depending on anything. They are independent. why the derived quantity, they depend on what, on other quantity to be able to what, get them or calculate them. So we move further to what we discussed by the what, by the unit. And now, as we are talking about quantity, now let me tell you about quantity. Quantity is made up of two basic something. The value. If I said 2 hour, 2 hour is a time, which is a quantity. But that quantity is made up of two parts: the number, the 2, and the hour. The 2 is the number, which is the value, okay, the quantitative measure. Why, what actually I'm measuring is what is the hour. Okay, so that hour is the unit. So that means in physics or science generally, we can't say you have 2. If you say 2, that 2 must be something, and that 2 must be what? Must be either 2 watts, 2 joules, 2 meter, 2 seconds, 2 ampere, 2 volts. So when you talk about quantity, it's made up of two parts: the word, the values, the quantity, the quantitative value, that is the numerical number you have, and the units at which you are what, you are measuring it. So that's why we say unit is a process of measurement, okay, by comparing two things between one another. So in physics, you basically make measure of what? Comparisons of a value. So unit is what? Is the measure of that quantity you are talking about. Is the unit that will tell us the measure of the quantity. Okay, so we say unit is the standard quantity used for what? Comparison. So just like the way we have fundamental quantity, we also have what? Fundamental unit. We can make an analogy from the definition. Fundamental quantity, these are the quantity on which other quantity are what? Are built on, or they are quantity that are the base quantity in what? In measurement. So we can now say what? Fundamental unit. These are the units of what? Of fundamental quantity. That is, they are the unit on which other physical units are what? Are measured or stand for. They are the standard. Then we have the derived quantity. Derived quantity, these are quantity that what? That we get from manipulation of the fundamental quantity. So the derived quantity now also have their own unit, that is their measurement, their system of measure, the value, the system on which we measure them. So that is also now have what we call what? Derived unit. Derived unit are units that what? That are dependent on what? On the fundamental unit. So the choosing standard for measuring of physical quantity, which has the same measure as that of the quantity, is called what? The unit of that quantity. Okay, so the unit of the quantity is the word, the standard of measurement of that quantity, which has the same measure of what? As the quantity. So what are the characteristics of make something a quantity? You know, for us to have a quantity, we must have this. So we are going in depth in this because for the JAMB student, these are the technical things that they will ask us beyond what WAEC may not go into. So what are the choices? What the characteristics? The unit must be suitable in what? In size. Okay? So that it must be suitable for us to use. It should be accurately defined. And that is, if we said 1 hour, we must be able to what? To measure that 1 hour. So number 3, it should be easily reproducible. Okay? If I'm measuring 1 meter, I should be easily produce the meter at any point or at any point in time. That will aid us to develop a device to measure the what? The quantities using that unit. So if I say 1 meter, anywhere I have, I should be able to produce a kind of device to measure the meter. 4, it should not change with time. If 1 meter 20 years ago should be 1 meter now. 1 meter in the time of Newton should be the same meter that Einstein used during his own time in the 90s. It's the same thing that we are using now in the in the 21st centuries, in the second decade. In the next 50 years, 1 meter should still remain 1 meter, in which the next generation of scientists will use. So it shouldn't change with time. 5, the unit must have a characteristic of universally acceptable. 1 meter in Nigeria is the same thing as 1 meter in Tokyo, in Japan, which must be the same as 1 meter in Dubai. It must be same 1 meter in Alaska. It must be same 1 meter in India, precisely, let's say Calcutta, or in New Delhi. There must be a standard of measuring this thing, and they must be the same.